MOXOFF and what we do during our everyday work, and how we deal with simulations, HPC methods, and mathematical modeling work in general. I see that most of you have a copy in your hands. I hope not to make you necessary for you in this presentation. So let's start. With MOXOFF, formally, it is a spin-off company from Politecnico di Milan. In this sense, we are a sort of cousins of Optimal, who just did its presentation earlier. And but we were born with a particular mission, that is to operate in a technology transfer approach, aiming at transferring and promoting all the mathematical methods and models that are developed in the main universities and research centers, and apply them to industrial processes, and to make industries able to use these advanced numerical methods and mathematical models to bring innovation in their process and products. We also then scout the market to find new opportunities to do that. And how we do this? In particular, we are basically a company focused on applied mathematical services. Of course, this is to be intended in a wider sense, as it includes also statistical methods, but also software engineering capabilities to implement actually software and codes that, including those mathematical models and services, can be exploited by industries. We will see later some examples. And basically, we provide consultancy services and software custom solutions to our customers. And especially in the last years, months actually, we are developing new vertical software products for very specific applications. Who we are now, we are a team of 17 people. Most of us are mathematical engineering. Actually, I'm an exception, as I'm an aerospace engineer. I have mathematical specializations due to my working experience, as most of us have. MOXOFF was born in 2010, so now it's almost 5 years, active from 5 years, and we have developed in this period more than 50 maths projects, that is, projects with companies based on a mathematical approach. And our basic feature is that those methods are not specialized to a particular industrial sectors, but they can be applied to a wider range of industrial applications. So let's see how we can do that, and which are our skills in particular. So the first group of skills is included in what we call modeling intelligence. That is the capability of comprehending, understanding, developing mathematical models, couple them into multi-physics application, for example, aiming at representing a particular physical phenomena or a particular physical phenomenon or a manufacturing process, for example. These methods then allow us to perform simulations at different levels, so 3D, 1D, coupled multi-scale simulations, and optimization analysis on processes or products. The other great branch of our skills is based on data intelligence, that includes all the techniques and approaches to analyze big data, and to big data, not only raw data coming from computation, for example, or experimental data, but also images. So it includes also image processing and something like that. As I said before, all these competencies are then coupled with a strong software engineering approach that is the way through which we can provide our customers with all these advanced mathematical features. A software tool that can be used inside the company, inside the industries to face their problem. This is
overview of some logos and some companies that are our customer actually. It is a small part, I think, but you can see that they belong to very different industrial sectors. We from manufacturing, and we'll see later on an example of this, from energy, oil and gas, but also sports, other manufacturing applications, and food. For example, food here, and in other cases. In particular, in food, we are developing a strong mathematical knowledge. In fact, we were at Expo in Milan for 1 day of presentation of MOXOFF. We will be there again on September for another day of presentations to spread how mathematical methods can be used also in the food industries to, for example, improve food sustainability, food conservability, and avoid food wasting, for example. Then you can see also a different sizing of companies that are our customers. We have very big international companies, but we also have very small, this one, very small companies. This one in particular is an Italian manufacturing company, which is, and they build the boat for the Olympic Games. They are 10 people, but they are the front-end manufacturing in their fields. So let's see how we can provide some solution to such a wide range of industries. This is our approach. So we basically start from the customer need. So the starting point is a problem, an industrial problem we are asked to approach. Then we firstly try to comprehend which is the physics ruling these particular phenomena or problems. We exploit the available data to have a knowledge of the problem, and then with a sort of engineering and coupled with mathematical creativity, we formalize the problem in a conceptual model that is basically a list of equations. Then we can solve these equations with the most advanced and suited numerical methods. Note, this phase is conceptual. We can use already existing softwares. We do not have any software house pushing us to use a particular software. We can suit customer needs. We can choose the right one. We can deal with commercial open source softwares. But at the end, what we provide is a problem solving and the solution tools. This may consist in results, analysis, interpretations, or typically on a customized integrated simulation environment, which is a software tools that can be used by our customers to approach and simulate and try to have a support tool to face their problems. I will go through now a short example of of our projects. The first one is mainly related to these two areas, so modeling and numerical methods. We saw before an image of a motorcycle. The objective there was to optimize the comfort in terms of wake. Now the problem is focused on the helmet. So the problem is to optimize the helmet manufacturing process to give a product that is comfortable from the point of view of the noise of the sweating perceived by the people wearing the helmet, and from the capability to resist the impact. That's the first mission of a helmet. This project has been carried out in collaboration with MOX, but what we do what we have done in this project is to develop some simulation modules. The first one is based on Openfoam and is a 3D external aerodynamics simulation setup to try to understand how the air flows around the helmet. This can give us the flow, for example, inside the ventilation systems, where we have developed a more sophisticated models, 2D models, but accounting for aerodynamics, thermofluid dynamics, two-phase flow. You have sweating, you have air combining each other, porous media, the comfort tissues inside the helmet, and a model for human head, for a sweating human head. This is aiming at considering all the phenomena that happens when you wear an helmet and you produce heat that is translated into sweat. In parallel, there's another simulation module to face the problem of helmet comfort, that is a vibroacoustic model for noise propagation inside the helmet. This has been implemented in this software speed that was developed for another application, elastodynamics, seismic wave propagation in the Earth, but the physics is the same. So what we did was to take this software and apply it to handle the case of the helmet. That is in some way a layered system as the Earth is. Finally, we have added another simulation module that is for crash simulations, and in particular to design helmets so that they can comply, first of all, with the safety of the drivers and to comply with the European regulations. All these modules are gathered in a dedicated tool, a software tool, which is structured with a client-server architecture. And we have a database, and so it's basically a, well, the main thing is not related to the architecture of the software, but to the fact that it's dedicated to simulate a specific tool, that is the helmet. And this can give a support in engineer design to design the helmet and try to couple the usual experimental way of designing helmet. Now, which is the further step? The further step is to exploit this platform at its full potential. As you may imagine, this simulation can take a very long time to be performed in a great variety of helmets and different configurations. So the HPC challenge in this background is to get to a target hour simulation for one helmet of 50,000. Of course, you have not the time to do all that simulation in one classical architecture or hardware resource, but you need to go towards HPC applications. That's why MOXOFF joins the Fortissimo project in collaboration with Cineca, which will provide their HPC expertise and resources, and coupled with our industrial partner that will provide instead user experience and the validation of the whole workflow, we want to port this architecture on this platform on an HPC architecture. This will give us the opportunity to develop a web-based simulation as a service on-demand services encapsulated in the Fortissimo workframe that we can then exploit to publish all our tools and to make them accessible to a wider range of users and bring, in this way, innovative products and services on the market. Just a few case again on our expertise, statistical methods and software engineering. So the first one is, okay, apart from the actual application, here we are dealing with big data analysis and data coming from sensors in real time. So you have a very huge quantity of data that you need to process to identify trends, to classify the kind of signals, to be able to predict any failure that the system may have. Where is the HPC challenge? Where you can see some number, 1 terabyte of raw data to be processed, almost 1 terabyte of data on the specific test case and on the database to be processed. And the computational time is quite long, but it's not so long, but you do not have time to do all that because you need to have real-time indicators where real-time is, let's say, some seconds, a few seconds, but the idea is you do not have all this time to process all this huge quantity of data. So we are not, so MOXOFF is going to is encountering such kind of problems very often in the very recent projects. So that's why the possibility to join the Fortissimo marketplace could be a great opportunity to make our software even more, to provide them with even more performance. The second one, I told you previously about sports. We are working for the Italian Federation of Volleyball, developing a software tool for video analysis. So you can film the athletes, the players, during trainings, and you can then reconstruct the movement to find the optimal trajectory of their body, to optimize the effect of a particular technical movement. Then we have a statistical analysis of the tactics of the players during the game. I don't know if you are familiar with volleyballs, but there are a lot of technicians acquiring data during the match that then can be processed and analyzed by the trainer, by the volleyball coach. So our idea is to enlarge this process, automatize this process, and customize the output so that the trainer, the coach, can be all his indicators ready to be applied during the match. And this is in particular developed for the second touch technical exploration, and it is a software that is one of the vertical applications we are developing right now. Again, where is the HPC challenge? Well, we have a lot of movements to be recorded and analyzed, and the analysis typical took 800 minutes each, which is more or less 1 day, we can say. But again, you do not have all those time because training are taken every day. So you want to take the videos, elaborate the data, interpret the data, and then the day after apply what you get from the analysis. And these are techniques that can be also applied to other sports. A typical example is the National Baseball Association in the US, where all these techniques are very used and applied to analyze the game. Okay, last example of one of our products is Matesia. Here we're going towards a different system that may be in some way a lot of point of contacts with the Fortissimo marketplace. Matesia is basically a website consisting in a crowdsourcing platform dedicated to applied mathematics, modeling, statistics, and optimization. So please note crowdsourcing and not crowdfunding platform, because its main objective is to create a link between industries, the pitchers that are looking for innovative solution based on mathematical approach, and people, the brainies, who are able to give them the answers. The platform is so, like the many crowd, it's set like many crowdsourcing platform already existing, but the innovation here is that it is for the first time applied to a mathematical approach. How does it work? Basically, the pitchers put a challenge, put a problem in a sort of mathematical framework in the platform, and they put a budget that they will grant to people who will solve them. And from the other side, the brainies can read this problem and can provide their solution in terms of proposal of activity. Among all these proposals, the pitcher choose the right one, which is the one who wins the challenge, and then outside the platform will hence perform the project in cooperation with the pitcher. There's a third figure here that is the core of the link between these two entities, that are the tools and service providers. Those people are the people who have the softwares, the resources, the tools, the software tools, anything that can help the brainy to perform the project with the pitchers. So we can have here software house or HPC centers or other one. So the platform is online from December the 1st, 2014, and there are almost 600 brainees. These are not yesterday data, just 1 month data hold, and they are organizing researchers, professors, consultancy companies, big consultancy companies, single brainy, students, freelance, consultant. It's very variegate, but in common they have the capability of approaching a physical problem with mathematics or simulations. And this is an overview of the pictures, so the companies that have posted their problem on the platform. You can see some famous name, other ones are coming. For example, Cineca with their spin-off SGS are going to enter the platform. And as well, we are talking with the Fortissimo people to, in particular, Guy and Claudio, again, on how to try to find a connection between Fortissimo, the Fortissimo marketplace, and Matesia to cooperate to push the business in some way together. And you can see that in a few months, 8 projects have been performed for a total gaining value of almost 200,000 euros. Then Matesia is going to be subject to an advertising campaign in the following weeks, so we hope it can be an opportunity for all those actors to find new opportunity of business. And this is another kind of product we have on our portfolio. And okay, so finally, this going back to MOXOFF, we are located in Milan, Italy, and we can also find us in the most famous social places. And finally, this is me, and I thank you for the attention.